Hi students, today we are here to learn about intermediate second year 2A chapter 6 binomial theorem. Okay, so in that today we will see all the important formulae and the points which have to be remembered before proceeding to our problems. Okay, so and this is the important chapter. So you are going to get two long answer questions and one very short answer question. So you can score 7 plus 7 plus 2, 16 marks if you are thorough with this chapter. Okay, so first we'll proceed with the important formula. So what is binomial? Binomial means two terms connected by either plus or minus sign. Okay, two terms connected by either plus or minus. Okay, like we have come across many expansions, right? Like x plus y whole square, x plus y whole cube. Okay, so in all of this we have x and y connected with each other, right? So now, do you know what is Pascal triangle? So what is Pascal triangle? So in your textbook, page number 204, it is given. So you can go through that, but I'll explain you as well. So like this is the triangle in the reverse way, and if these two are the coefficients, okay, of an equation, then a plus b. Here we write it as a plus b. Okay, this is called as Pascal triangle. Suppose we'll consider x plus y whole square. Okay, then this can be written as x square plus 2xy plus y square. So that means here this can be written as 1. So 1, 2 and 1. These are the coefficients, right? So now what is x plus y whole cube? This can be written as x cube plus 3xy plus 3x square y plus 3xy square plus y cube. So here 1, 3, 3 and 1. These are the coefficients, right? So now in the similar way we will see what is there in the textbook. Okay, so here if the index is 1, if the index is 1 means this is the index. Okay, this is the index. So that means if the index is 1, in the sense this will be x plus y whole power 1. So here index is 1. Okay, if index is 1, then the coefficients will be, what are the coefficients? They are x plus y. So 1 and 1, right? So coefficients will be 1 and 1. Okay, so now if index is 2, that is x plus y whole square. Here the index is 2, right? So if we consider this, then it will be x square plus 2xy plus y square. Okay, so that means here 1 plus 1, that is 2. Okay, 1 plus 1 is 2, and again this will be 1 and this will be 1. Okay, so always 1 comes at the end, and addition of the above triangle comes in the middle. Okay, so for suppose if we'll consider x plus y whole cube, so index is 3 here. So what will be the case here? It will be 1 plus 2. Okay, 1 plus 2, that is 3. Here again 2 plus 1, that is 3. So again here it will be 1 and 1. Okay, in the similar way we can write for index 4, 5, everything, so on up to n. Okay, so that is how we got the binomial theorem. Okay, so before that, binomial theorem for positive integral index. Okay, so binomial theorem for positive integral index. Okay, so in the expansion of x plus y whole power n, like not only x plus y whole power n, suppose if we see, here. So in the expansion of x plus y whole power n, okay, as we proceed, if you observe, as we proceed from left to right, the index of x decreases and the index of y increases each time by 1. Did you observe that? So that means the coefficients in the expansion of x plus y whole power 1 are 1 C0, okay. In the binomial theorem, we can write it as this, okay. This will be actually n, okay, nc0, nc1. So this is our n, so I'm writing it as 1 C0 here, okay. So for x plus y whole square, that is, here our n is 2, right? So 2C0, 2C1, 2C2, okay. So similarly for x plus y whole cube also it is same. So for x plus y whole cube it will be 3C0, 3C1, 3C2 and 3C3, okay. So here this is n and this is our r, okay. N will always be same, okay. N will always be same, but r, it is a range from 0 to n, okay. So it is a range from 0 to n. So that's why we got it as 0, then 1, 2 and 3. So this is our n, right? So r is the range from 0 to n. So now the binomial theorem formula. We are learning about the binomial theorem formula now. So that will be x plus a whole power n is equal to nc0 into x power n a0, okay, plus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a power 2. So plus so on up to ncr into xn minus r into a power r. This is our rth term. Okay, I'll tell you about that. So plus so on up to ncn into x power 0 into a power n. Okay. This is a binomial theorem formula which you have to remember. Actually, no need to remember if you understand the earlier concept. So if you want, you can go through again in your textbook, then it will be easy for you. So binomial theorem proof I'll be telling you in the long answer questions when we'll go through the next video, okay? So now in general we can write this formula as let n be positive integer here, okay, let n be positive integer and x and a be the real numbers, then x plus a whole power n can be written as summation of, that is sigma r equal to 0 to n ncr x power n minus r into a power r, okay. So this is the general formula. So then here we have 3 bits here. Then the expansion of x plus a whole power n, it has n plus 1 terms, okay. And then the rth term in the expansion of x plus a whole power n, it can be written as tr is equal to nc r minus 1 into x power n minus r plus 1 into a power r minus 1, okay. So there is a condition here for 1 less than or equal to r less than or equal to n plus 1, okay. So r plus 1th term now, okay, r plus 1th term. So actually what is r plus 1th term? In the expansion of x plus a whole power n, we have r plus 1th term also we get there. So that is called the general term, okay. We call it as a general term and it can be written as tr plus 1 is equal to ncr into x power n minus r into a power r. Okay, this is for 0 less than or equal to r less than or equal to n. Okay, so now the trinomial expansion. Okay, this is also important for us. Okay, so the trinomial expansion, like you can see in the textbook page number 208. Okay, so if n belongs to natural numbers and a, b, c belong to real numbers, then a plus b plus c whole power n can be expanded using the binomial theorem. Okay, by taking a as the first term and b plus c as the second term. Okay, and I'll just write it here. So a plus b plus c whole power n is equal to a plus b plus c whole power n, that is equal to sigma of r is equal to 0 to n ncr into a power n minus r into b plus c whole power r. Okay, so this can also be written as like another form of this expansion is a plus b plus c whole power n is equal to sigma of 0 less than or equal to p q r less than or equal to n p plus q plus r is equal to n. So n factorial by p factorial into q factorial into r factorial into a power p, b power q and c power r. Okay, now in this, if the expansion contains r plus 1 terms, then the number of terms in the expansion can be written as like number of terms in the expansion of a plus b plus c whole power n. This can be written as sigma r is equal to 0 to n of r plus 1, r plus 1, that is equal to n plus 1 into n plus 2 divided by 2. Okay, you have to remember this. Then coming to middle terms, so in x plus a whole power n, okay, in x plus a whole power n, in the expansion of this, if n is even, okay, if n is even, then the expansion of x plus a whole power n has n plus 1 number, that is odd number of terms. Okay, it will be having odd number of terms. Then expansion has n plus 1 terms, okay, which is odd. Okay, so that means there is only one middle term, which implies there will be only one middle term, right? So how to find that middle term? Okay, which is the n by 2 plus 1th term. Okay, the middle term is this one. And how to find that one? We have a formula, t n by 2 plus 1, that is equal to c n by 2 into x power n by 2 into a power n by 2. Okay, so this is the formula to find the middle term. Now if in x plus a whole power n, if n is odd, okay, if n is odd, then expansion will be having n plus 1 terms, right? So that will be even here. Okay, expansion has even number of terms. Okay, so that means there will be two middle terms here. Okay, are you understanding? So there will be two middle terms here, and they are n plus 1 by 2 and n plus 1 by 2 plus 1th term. And how to find those? T n plus 1 by 2 is equal to n c n minus 1 by 2, okay, into x power n plus 1 by 2 into a power n minus 1 by 2. Okay, and how to find the next term? T n plus 3 by 2 is equal to n c n plus 1 by 2 into x power n minus 1 by 2 into a power n plus 1 by 2. Okay, so these are the formula to find the middle terms. So as we have seen above in x plus whole power n, we are having the coefficients as nc0, nc1, nc2, so on up to ncn, right? So these are the coefficients. These are called as the binomial coefficients. Okay, these are called as binomial coefficients. So, and these are the binomial coefficients when corresponding to n. Okay, and if n is fixed, then we will usually denote these coefficients by C0, C1, C2. Instead of writing it as NC0, NC1 all the time, we can write it as C0, C1, C2, so on up to Cn. Okay. So in this notation, if you consider the coefficients, you can compare and check, like Cr will be equal to Cn minus R. Since we have NCR is equal to NCn minus R. Okay, so that is like C0 should be equal to Cn, C1 is equal to Cn minus 1, C2 is equal to Cn minus 2, etc. Okay. So now, so binomial expansion of 1 plus x whole power n, this can be written as nc0 plus nc1x plus nc2 x square plus so on up to ncn x power n. So this expansion is called as standard binomial expansion. Okay, this is the standard binomial expansion. So actually here I am telling each and every point because this chapter is very important. Okay. So based on this statement now, we will see the theorems, like general theorems. So like if n is positive integer, then the thing you have to remember is you can prove this, but you have to prove this, but if you remember it, then it will be easy for you to solve the problems. Okay, so C0 plus C1 plus C2 plus so on up to Cn is equal to 2n. Okay, then in the second bit we have two bits again. So C0 plus C2 plus C4 so on up to Cn is equal to 2 power n minus 1 if n is even, and C0 plus C2 plus C4 plus so on up to Cn is equal to, sorry, Cn minus 1 is equal to 2 power n minus 1 if n is odd. Okay. Similarly, for the odd one, C1 plus C3 plus C5 plus so on up to Cn minus 1 is equal to 2 power n minus 1 if n is even. Okay, and C1 plus C3 plus C5 plus so on up to Cn is equal to 2 power n minus 1 if n is odd. So actually you can find the proof of these theorems in page number 210. So if you go through the proofs, then it will be easy for you to understand these statements. Okay, and if the coefficients are in arithmetic progression, okay, if the coefficients are in arithmetic progression, that is 1, 3, 5, so on up to 2n plus 1. Okay, then like we have a statement even for this. Okay, that can be written as AC0 plus a plus d c1 plus a plus 2d into c2 plus so on up to a plus nd cn will be equal to 2a plus nd into 2 power n minus 1. So actually if you remember this statement, then it will be easy for you to solve the problem, because we have problems uh, for this AP also. Okay. So next, the numerically greatest term. So numerically greatest term in 1 plus x whole power n. Okay, you can find this in page number 214. Okay, so in the binomial expansion of 1 plus x whole power n, the rth term, that is tr, is called as the numerically greatest term. Okay, so if mod of tk is less than or equal to modulus of tr, that is for 1 less than or equal to k less than or equal to n plus 1. Okay, now let n belongs to natural numbers and x belongs to r minus the set of 0, and m is equal to n plus 1 into mod x divided by 1 plus mod x. Okay, here for any t belongs to r. Okay, so this t is the integral part of t. Then if n plus 1 into mod x divided by 1 plus mod x is not an integer, okay, if this is not an integer, then tm plus 1 is the numerically greatest term. Okay, and if n plus 1 into mod x divided by 1 plus mod x is an integer, then mod of tm is equal to mod of tm plus 1, and tm and tm plus 1 both are numerically greatest terms. Okay, so students, these are the important formula which we have to remember and which we'll be using to solve our problems. Okay, so these are the list of very short answer questions which we'll be seeing in our other videos. So totally there are 24 very short answer questions. Okay. And there are 26 long answer questions. This is the list of long answer questions. So that's it, students. These are the important formulae and the points which have to be remembered, and also the list of important questions which are going to be appearing in your exam. So I'll come again with the solved problems of this long answer questions and very short answer questions in my next videos. So please subscribe my channel. Please like, share and subscribe if you like these videos. Okay, bye.